students. Today we are going to see yet another important and interesting topic in histology, periodontal ligament, shortly called as the PDL. Now PDL we know is a soft tissue that is connecting two hard tissues. On one side you are having the cementum of the root, whereas on the other side you are having the alveolar bone. So one side you have cementum, the other side you have alveolar bone. So these cementum and alveolar bone, they are hard tissues, and in between these two you have a soft tissue, that is your periodontal ligament. Now periodontium, the word periodontium is used to denote all the four different structures, that is your periodontal ligament, cementum, alveolar bone, and also your dentogingival junction. All this together is called as periodontium. But the word periodontal ligament is specifically denoting only the soft tissue that is seen in between cementum and alveolar bone. It's a specialized form of connective tissue. So it's not like any other connective tissue. Something is special about it. What is special, we will see. It is special because it is connecting two mineralized tissue. This is a HND stained decalcified section of tooth. You can see that you have periodontal ligament in between. So this side you have cementum and the other side you have the alveolar bone. So the average thickness of periodontal ligament. So how can you assess this thickness? Yes, you cannot assess it clinically. You cannot assess it with your naked eye, but it can be assessed in a radiograph. Yes, the average thickness when you take a radiograph is ranging between 0.15 to 0.3. Now, this is a very important MCQ question, very frequently repeated in the previous year question papers. The average width or thickness of the periodontal ligament ranging between 0.15 to 0.38 millimeter. So, when you take this periodontal ligament, it is not, the thickness is not uniform everywhere. So, it will be thick towards the cervical portion of the tooth. It will be thick near the apical portion, but when it comes to the middle third of the root, it will be having a thin appearance. So it is like a hourglass. Hourglass means it will be thick in the cervical region, it will be thick in the apical portion, whereas in center it will be thinner. And when you take a radiograph, like an intraoral periapical radiograph, like shown in this picture, how will this periodontal ligament appear, or this periodontal ligament space? It will appear as a radiolucent space. So we all know the basis of radiographs. So in the radiographs, the images are appearing dark or black and white. That is, whichever tissue is a hard tissue, which is a mineralized component, that will appear white, radio opaque. You call it radio opaque in radiological terms. Whereas any tissue that is a soft tissue or which is not mineralized, that will appear as black areas. Okay, that is called radiolucent. So here in this case, periodontal ligament is a soft tissue. There is no mineral content there, and that is why it is appearing as a radiolucent space. So on one side you will see the cementum outline, that will be radiopaque line because it is a hard tissue. On the other side you will see alveolar bone. So alveolar bone outline will also be seen as a radiopaque line. That is also hard tissue. So between two radiopaque lines, you will see a radiolucent space. That space is denoting the periodontal ligament space. Microscopically, when you look under the microscope, so what is periodontal ligament made up of? Now, before that, during tooth development, you have different structures forming from different parts of the tooth germ. Now, you have enamel organ, you have dental papilla, and you have dental sac. As the name only suggests, from the enamel organ, enamel is arising. That is why the name itself is enamel organ. From dental papilla, two structures are arising, dentin and pulp. So please remember DP. DP stands for dentin and pulp. That is dental papilla. Whereas dental sac, which is also called dental follicle, the other name for dental sac is dental follicle. Three structures are arising: cementum, periodontal ligament, alveolar bone. So the origin of an alveolar bone is actually dental sac or dental follicle. That is nothing but the ectomesenchymal tissue. So under histologically, when you see, even dental papilla is also an ectomesenchymal tissue. So both dental papilla and dental sac are ectomesenchymal tissue. So from dental papilla you get pulp, from dental sac you get periodontal ligament. So there are a lot of similarities between pulp and periodontal ligament. So if you have to compare pulp on one side and periodontal ligament on one side, what are the similarities? First one is both are soft tissue. Whereas all the other tissues like enamel, dentin, cementum, bone, they are all hard tissue. Only pulp and periodontal ligament are soft tissues. Number one. Number two, by origin, both of them originate from ectomesenchyme. But only difference is in pulp, the ectomesenchyme is dental papilla, whereas in periodontal ligament, the ectomesenchyme is dental sac. But otherwise, both are ectomesenchymal derivatives. Therefore, histologically, when you look under the microscope itself, the structure of pulp and periodontal ligament, which means I am telling the contents of this pulp and periodontal ligament will be almost similar. So, what is the structure of this periodontal ligament? It is made up of, it is a specialized connective tissue. So, any connective tissue will have three elements: the cells, connective tissue cell, extracellular substance, outside the cells, what are the things that you have, and then the other connective tissue elements. Other connective tissue elements includes blood vessels, nerve fibers, lymphatics, everything. So any connective tissue in the human body is going to have all these three structures. So periodontal ligament also has the same thing. But how is this unique is that the cells are different here. So what are the types of cells that you see in the periodontal ligament? They are classified based on their function into 5 types. So one is the synthetic cells. Synthetic cells are called formative cells, otherwise known as synthetic cells. Then you have resorptive cells. Resorptive cells are destructive cells. Then the progenitor cells, from which all the other cells arise from. They are the originating cells. So they are the progenitor cells. Then the special type of cells is cell rest of Malassez. This is very unique to PDL. You don't see cell rest of Malassez anywhere else. They are very, very characteristically seen only in the periodontal ligament. And of course, the defense cells. Any connective tissue will have the immune cells or the defense cells, immune cells. So each of these cells will have specific function. So first going to the formative cells. Formative cells are of 3 types. First is the fibroblast. Okay, that is the predominant type of cell in the periodontal ligament. And on one side, close to the cementum, you will have cementoblast. On the other side, which is close to the alveolar bone, you might have osteoblast. So the 3 types of formative cells, please note all these cells are blast cells. Anything that ends with blast, they are formative cells. So fibroblast, cementoblast and osteoblast are the 3 types of formative cells that you see in the periodontal ligament. Of that, the predominant one is the fibroblast. So the fibroblast here, name only suggests they help in the formation of collagen fibers. So the fibers that you are seeing in the connective tissue, they are formed by fibroblasts. But the unique feature of fibroblast is that the fibroblast itself is having dual function. Dual function means 2 functions. Whenever there is a need, they will help in formation of fibers. And whenever there is a need, they help in destruction of the or resorption of the fibers. So the fibroblast itself can act both as a formative cell as well as resorptive cell. According to the need, the function will change. That is the unique feature about this fibroblast. When the cell is actively functioning, you call it a fibroblast. But once the function is over and it has become a more differentiated cell, you will no more call it fibroblast, then you will use the term fibrocyte. But when you come to cementoblast and osteoblast, they have unique function, only formation. So osteoblasts help in formation of bone. They are seen lining the surface of the alveolar bone. Whereas when you come to cementoblasts, they are seen lining the surface of cementum and they help in the formation of cementum. When you go to resorptive cells, the second group of cells, we have again 3 types. One is fibroblast. I already mentioned fibroblast is dual function. Cementoclast and osteoclast. So clast cells are always destroying or resorptive cells. So fibroblasts can either be formative or resorptive. They help in either formation or resorption of the fibers in the connective tissue. Whereas cementoclast helps in resorption of the cementum. And osteoclast, as the name only tells, helps in the resorption of the bone. Now this osteoclast is very, very important because a lot of questions are asked regarding osteoclast. One is the origin of osteoclast, that is from the blood monocyte. Circulating blood monocytes, when they come out of the blood and circulation, when it reaches a tissue, then it is used, the term macrophage is used for that. And in each tissue, the macrophage is having different name. In bone tissue, The macrophages are called as osteoclast. So actually the origin for an osteoclast is the blood monocyte. That is number one. Number two, the function of osteoclast is bone resorption. Why is that bone resorption happening with the help of osteoclast? Because osteoclast has a special type of enzyme that's called acid phosphatase. So we all know that acids have the capacity of demineralization. So this osteoclast will create an acidic environment because of acid phosphatase enzyme. This acidic environment will cause demineralization or removal of calcium and phosphate from the bone. So when calcium and phosphate is removed, only the organic content of bone will be present, and that will be destroyed by proteolytic enzymes. So that is how bone resorption is happening with the help of osteoclast. And the important thing about osteoclast we need to know is, unlike the other cells, any cell of the physiological cell present, osteoclast is unique because it is a multinucleated giant cell. So you can see in this picture here, this is osteoclast. One cell will have multiple nuclei. So it is multinucleated giant cell. Why you call giant cell? Because the cell size is very big. So multinucleated giant cell is how the appearance of an osteoclast will be under a microscope, like how you see in this picture here. A large cell with multiple nuclei inside that. That is the unique feature of osteoclast. So other than the formative and resorptive cells, you also have progenitor cells in the periodontal ligament. The progenitor cells are nothing but either they can give rise to defense cells or they can give rise to formative cells. Whenever according to the need, whatever is the need, accordingly from the progenitor cells, different type of cells will form. Either a fibroblast will form or an osteoblast will form. Anything can form. That is the function of a progenitor cell. Whereas one unique cell that is seen in PDL, which is not seen in any other connective tissue or any other part of the tooth or bone, is cell rests of Malazes. Malazes was the person who first described it. What is this? They are remnants of Hertwig's epithelial root sheath. So Hertwig's epithelial root sheath is a structure during tooth development. It is very, very important for root formation. Okay. Whenever root formation is over and cementum is formed, this Hertwig's epithelial root sheath will disintegrate, but the remnants will be left behind in the periodontal ligament. Those remnants are called as cell rests of Malazes. Why they are called cell rest? Because they are resting cell. They are always in the G0 phase. They will not undergo cell division or mitosis under normal condition. But when stimuli is given, they will start multiplying, and from G0 phase, they will enter into G1 and S phase. That is, they will enter the cell cycle and they will start multiplying only when a stimuli is given. So what will happen that time? When a stimuli is given and they start multiplying and proliferating, then it will lead to pathology. Either a odontogenic cyst can form from that or odontogenic tumors can form from that. So this cell rests of Malazes are also called as odontogenic rest, because it is related to tooth formation. Odontogenesis means tooth formation. So these rests are formed or associated with tooth and root formation. These rests are also called as odontogenic rests. We have two types of odontogenic rests. One is cell rests of Malazes. The other one is cell rests of Serrae. So what are cell rests of Serrae? Cell rests of Serrae are remnants of dental lamina. So you have two types of cell rests. One is cell rest of Malazes, one is cell rest of Serrae. Both are resting cells in normal condition. When you give a stimuli, they will proliferate and they may give rise to pathologies like odontogenic cyst and tumors. They are related to tooth development, so they are also called as odontogenic rest. So very, very important. A lot of questions are asked on this odontogenic rest. Out of that, only cell rest of Malazes is seen in the periodontal ligament, not cell rest of Serrae. The normal location for cell rest of Serrae is either in the gingiva or it can be seen within the jaw bones. That is for Serrae. Whereas Malazes are mainly seen in the periodontal ligament. So all these are cells. Okay, defense cells. Defense cells can be a neutrophil, lymphocyte, mast cells, any of this. So whenever any bacterial or any antigenic exposure is seen in the periodontal ligament, these defense cells will attack them and try to remove them from the periodontal ligament. So you have formative cells, you have resorptives, you have progenitor cells, cell rest of Malazes and defense cells. Other than the cells, you have extracellular substance. Outside the cell, what do you have? You have one is fibers, the other one is ground substance. So what are the fibers present in the periodontal ligament? Mainly collagen fibers. The first major component is collagen fiber. You also have some amount of elastic fibers and reticulin fibers. So three types of fibers make up the substance of the periodontal ligament: collagen, elastic fibers and reticular fibers. And the space between the cells and the fibers are combined together, and that forms the ground substance. Ground substance is nothing but a main component present in between the cells as well as the fibers. Two types of ground substance are seen: proteoglycans and glycoproteins. So anywhere you see ground substance, not only periodontal ligament, we see only two major types of ground substance: proteoglycans and glycoproteins. As the name only suggests, they are combination of carbohydrates and proteins. So carbohydrates and proteins in different combination will form proteoglycans and glycoproteins, and these two forms the major component of ground substance. Now fibers are the main content of periodontal ligament. I said mainly collagen fibers. Type 1 and type 3 collagen fibers are predominantly seen in the periodontal ligament. You also have some amount of type 7 fibers, but mainly type 1 and type 3. Now all these fibers which are seen in the periodontal ligament, they are arranged in a specific direction and they are given different names for that. So what are these different fibers? What kind of names are they given? So let us take a tooth like this. This is a molar tooth. So you have periodontal ligament like this. Let us assume this is alveolar bone. Okay, this is alveolar bone. This is bone here. So this is periodontal ligament. What you see in between is the periodontal ligament. So what happens here is all the fibers, whatever you see, will be arranged in a specific direction. Accordingly, you give the name. So the first group of fibers, which is seen crest of the alveolar bone to the cementum, that is called alveolar crest fibers. That is the first group of fibers. Alveolar crest. The name only tells you it is from the crest of the alveolar. Crest means the tip of the alveolar bone. From the crest of the alveolar bone to the cementum. That is the first group of fibers, alveolar crest group. Second group of fiber is horizontal group. Then oblique group. Oblique. It is running in oblique direction. So second is horizontal, third is oblique. Then when you come to the tip of the root, it is called apical fibers because it is seen in the apex of the root. Then when you come to the between the two roots, what you see is called interradicular fibers. That is number 5. So what happens here is based on the direction, you have 5 different group of fibers in the periodontal ligament. First is alveolar crest, then horizontal, oblique, apical and interradicular. This interradicular fibers will be seen only if you have multi-rooted tooth. If you have only single root, like incisors, canines or some premolars, you will not see interradicular fibers. Only in multi-rooted tooth or like molars and premolars you can have it. So all these fibers together are called principal fibers of periodontal ligament. So all these 5 group of fibers are named as principal fibers. So of all these 5 fibers, which is the most predominant, which forms the bulk, is the oblique fiber. This is very frequently asked as MCQ. So of all the fibers, which one is the most predominant? Bulk is made up of oblique group of fibers. So this will be, so biochemically, this principal group of fibers, they are named based only on the direction. But biochemically, what are they made up of? They are made up of collagen, elastin and reticulin fibers. So you have extracellular substance in the form of fibers and ground substance. Other than that, all the other connective tissue, like any other connective tissue, periodontal ligament will also have blood vessels, nerve fibers, lymphatics, and one special type of structures are seen in the connective tissue, which is called cementicles. So what are these cementicles? Now periodontal ligament is a soft tissue. In the soft tissue, sometimes calcified material will be seen. That calcified material can resemble a cementum, looks like cementum. So they are called cementicles. So this is somewhat similar to denticles that you see in the pulp. So in the pulp, which is also a soft tissue, you can see calcified material which will look like dentin. So they are called denticles. Same way, In periodontal ligament, you can see calcified material which will look like cementum, so they are called as cementicles. Not always, but sometimes you can see cementicles within the connective tissue element of the periodontal ligament. So just to summarize, periodontal ligament, like pulp, is a specialized form of connective tissue, which is actually the soft tissue that connects bone on one side, alveolar bone on one side, whereas on the other side, you have the cementum. Now, the bone which is seen on one side of the periodontal ligament is the alveolar bone proper. It is called alveolar bone proper. And radiographically, this alveolar bone proper is called lamina dura. And in a radiograph, you will see lamina dura as a thin radio-opaque line covering the tooth. Okay, so that is called as lamina dura, which is nothing but alveolar bone proper. So on one side you have alveolar bone proper, on the other side you have cementum. Connecting these two, what you have, that soft tissue is periodontal ligament. You have mainly the principal fibers of periodontal ligament: alveolar crest, horizontal, oblique fibers, apical and interradicular fibers. They are made up of not only collagen fibers type 1 and type 3, but also some amount of elastic and reticulin fibers. Other than the fibers, you also have ground substance in the connective tissue with blood vessels, nerve fibers and lymphatic vessels. Thank you.